So let's start the exercise questions. First question is, alpha particle is projected vertically upward with some speed in a region where magnetic field of magnitude 1 Tesla is there and direction is south to north. Find the magnetic force that acts on the alpha particle. So the first one, Q is 2 into 1.6 into 10 to the power minus 19 coulomb, because charge of alpha particle is twice that. Alpha particle consists of 2 protons and 2 neutrons. So the 2 protons give its charge. So charge of 1 proton is this much. So therefore multiply by 2. Then velocity is 3 into 10 to the power 4 kilometer per second. Let's convert it into meter per second. So it will become 10 to the power 7 meter per second. Magnetic field intensity is 1 Tesla. Now we know that the force is given by QVB. So 2 into 1.6 into 10 to the power minus 19 into 3 into 10 to the power 7 into 1. So force will be 9.6 into 10 to the power minus 12 Newton. Now using the Fleming's left hand rule, you can find that force will be towards west. In second question, we have electron projected horizontally with some kinetic energy. We have some magnetic field in vertically upward direction. Will the electron deflect towards right or towards left? And calculate the sideways deflection of electron traveling through 1 meter. So this is the second one. So let's say this is a situation so magnetic field, let's say, is like a particle is moving like this, and the magnetic field, so this is our magnetic field. Okay, this is our magnetic field. Let's say this is the distance x. So the particle will move like this. It will have some deflection. Let's say the deflection is s. So kinetic energy is given 10 keV, which will mean 1.6 into 10 to the power minus 15 joule, because 1 EV is equal to 1.6 into 10 to the power minus 19 joule. So this is kilo. So this conversion we have used here. Next, magnetic field is 1 into 10 to the power minus 7 Tesla. First part, electron will be deflected towards left. Electron will be deflected towards left using the Fleming's left hand rule. And second part, half mv square equal, the kinetic energy is half mv square, and from here velocity will be kinetic energy into 2 over m. Now F is QVB and acceleration will be QVB over mass of electron. So by S equal to ut plus half at square, half initial velocity is 0, so this will become 0. So half A is QVB over mass of electron into time square. So time can be x over v square. Time can be displacement over velocity. So ultimately displacement will be qb x square over 2me root ke into 2, because velocity is this much. So once you put all the values, all these values are there. So solving this, displacement will come out to be 0.0148 meters or 1.5 into 10 to the power minus 2 centimeters. This will be the displacement. In question 3, we have a magnetic field which exerts a force of this magnitude on a particle having charge 1 into 10 to the power minus 9 coulomb, which is going in xy plane. We need to find the velocity of the particle. So this is the third one. So what we have magnetic field in k cap direction, force like this. So in x direction the force is 4 into 10 to the power minus 10 Newton. Y direction it is 3 into 10 to the power minus 10 Newton. Now let's only consider x axis. So Fx equal to q v y and into b. Y velocity is y component, because remember force and velocity are perpendicular to each other. Okay, force is q v cross b. So v, b and f all are perpendicular to each other in cross product, in vector product. So what we will have vy equal to f over qb. So 4 into 10 to the power minus 10 over 1 into 10 to the power minus 9 coulomb into 4 into 10 to the power minus 3 Tesla. So Vy will be 100 meter per second. And similarly for y-axis, Fy will be qvx into b. So Vx will be f over qb. So this will give us after solving this you will get 75 meters per second. So 175. So velocity will be minus 75 I cap plus 100 j cap meters per second. Now this direction can be obtained using the left hand rule. Okay, the cross product formula is there, so using left hand rule you can find the direction. Sorry, this is the cross product, so you can use the right hand rule. Now in question 4, an experimenter's diary reads as follows: a charged particle is projected in magnetic field of some magnitude. Acceleration of particle is given. It is to be found out. The number to the left of I in the last expression was not readable. What can this number be? So this is the fourth one. So magnetic field is 7 I cap minus 3 j cap into 10 to the power minus 3 Tesla. Acceleration some value plus 7 j cap into 10 to the power minus 6 meter per second square. Now let's say this is x, okay, unknown value. So we know that magnetic field and acceleration are always perpendicular, so that is their cross product will be 0. So that is 7 into 10 to the power minus 3 into 10 to the power minus 6 minus 3 into 10 to the power minus 3 into 10 to the power minus 6. Cross product, it will be 0. 7x minus 21 equal to 0. X will be equal to 3. So just find the cross product and put it equal to 0. You will be able to find the value of x. Fifth question, we have a 10-gram bullet having charge 4 microcoulomb. It is fired at a speed of 270 meter per second in a horizontal direction. A vertical magnetic field of 500 microtesla exists in the space. We need to find the deflection of the bullet due to magnetic field as it travels through 100 meter. So this is the fifth one. What do we have? We have, let's say that the object bullet was moving in this direction, but its acceleration will be in this direction, so it will follow some path like this. So mass is given 10 gram, Q is 400 microcoulomb, so 400 into 10 to the power minus 6 coulomb. Velocity 270 meter per second. Magnetic field 500 microtesla, or 500 into 10 to the power minus 6 Tesla. So force on the particle QVB 4 into 10 to the power minus 6 into 270 into 500 into 10 to the power minus 6. So force will come out to be 54 into 10 to the power minus 8. Now acceleration will be 54 into 10 to the power minus 8, that is force, over the mass, that is 10 to the power minus 2. So it will be 54 into 10 to the power minus 6 meters per second square. Now velocity acceleration will be along k direction, okay, because the force will be in the k direction. So velocity along I direction and acceleration along k direction. So along x-axis, this equation we are using. So Vx is there, Vx is 270 and Ax is 0, acceleration is not there. So S equal to ut plus half at square. So S is 100, Vx is 270, okay, this can be Vx into time, and this is 0. So ultimately time will be 10 over 27 seconds. Along z direction, Vz is 0, Az is 54 into 10 to the power minus 6 meter per second square. So from here S will be half, this part will be 0, okay, this part will be 0, only this part will be there, as velocity is 0. T square, so it will give us displacement 3.7 into 10 to the power minus 6 meters. So this displacement is in z direction. In question 6, we have a proton released from rest in a room. It starts with some initial acceleration a0 towards west. When it is projected towards north with some speed, it moves with initial acceleration 3a0 towards west. We need to find electric field and the minimum possible magnetic field in the room. So this is the sixth one. So let's say charge and mass of proton are E and M. Force will be QP cross QP into E. MA will be EE. Force is MA, QP is E. So electric field will be MA0 over E. This will be towards east. Positive charge moves along the electric field. Now acceleration changes from A0 to 3A0. So magnetic force will be magnetic field, net acceleration produced by magnetic field is 2A0. Okay, so net acceleration is 2A0 because it is going from A0 to 3A0. So mass into 2A0, okay, acceleration, and we know that the formula for magnetic field is EV cross B. So from here magnetic field will be 2m A0 over EV0 and it will be downward. Magnetic field will be downward. In question 7, consider 10 cm long portion of straight wire carrying some current placed in magnetic field of 0.1 Tesla with 53-degree angle with wire. What magnetic force does the wire experience? Seventh one. Length is 10 cm or 10 into 10 to the power minus 2 meters or 10 to the power minus 1 meter. Current is 10 ampere. Magnetic field is 0.1 Tesla. Angle is 53 degrees. F will be I L B sine theta. So 10 into 10 to the power minus 1 into 0.1 into 0.79. Sine 53 degrees 0.79. So force will be 0.0798, approximately 0.08 Newton. This will be the force. Now this direction will be along perpendicular to both I and B. It will be perpendicular to both I and B. It can be found out using the right hand rule.